Hello, everybody. I'm going to talk about modern continuous delivery. The library and meets Docker is very, very small. You understand why. First of all, I don't want to talk about production system. Yesterday there were discussions about if Docker is a good choice for development processes or for production systems. So my point of view, I'm happy that yesterday we found that, is that we are going to talk about development processes or how Liferay is creating the product with the most quality and the fastest. Sorry. For that, I'm going to talk about continuous delivery, what it means for us, what are the challenges we found in this approach, and what the final solution we found here in the engineering team. Well, continuous delivery, I try to find a good description, a good quote, saying, summarizing what is continuous delivery. And this is the one I like the most. Continuously delivering value to customers. As like a continuous flow from developers' laptops to customer servers. Yeah? And the value is defined by the customer, not for us, for developers. So this is the one I think is the one I like the most. So if you follow the continuous delivery culture, you will be building the product with the most quality. Why? Because you will be forced to do the repetitive and harder task the more. So like releasing and deploying. You know that every time you deploy or create a release could be super hard. That's why you are creating it or doing it once a year, for instance. If you force yourself to doing it more, you will get the knowledge and the experience to be more prepared to do it more times. Doing that way, you will find bugs the soonest because you are doing it more times, maybe weekly or maybe daily. You will find the things that your customers don't want the soonest. So, and that is cheap. If you find a bug in production, this is very expensive. So try to do it the soonest. And this will be reducing the feedback loop with your customers, which is very important. But we are not we are a company that produces a product. So we don't have a production environment. So we have to find who are our customers. So we decide to find internal customers. And who are those internal customers? Other teams, developers, testers, QA, consultants, even non-sales customers. Sorry, even non-sales teams, like marketing or sales. We want to provide them environments to check that the product satisfies their needs. Everyone has their needs, and we want them to check that the soonest. So we start building automating the build, Gradle, managing dependencies, and we automate the testing. I think Joel was talking about the pull request tester yesterday during the conference. I will explain what it is. So we automate the testing, and we automate our internal deployments. This is our goal, the final goal. The pull request tester is a set of Jenkins jobs that does everything here. So we compile the GSPs, we check the semantic versioning, the portlet specification, the plugins are not broken. So every time a developer sends a pull request to another one, all this battery of tests are run. And this makes us confident about what the quality of that pull request. So we check with those application servers and those databases. And this is the result in GitHub. This is the last pull I sent to Brian, and it's longer than that, but it checks everything. You can check in now if one developer you want, their pull request queue and see what is executing. So now we are confident that the code is good, and we can merge to master, and we can release. Okay, we have the package. This is the one you know as bundle. Okay, and we have to operate it. We have to install in servers. So what are the challenges we found on this? First, we have old school IT procedures. We have to put that bundle in a server, physical or virtual, and run it, managing, health checking, etc. And another problem we found is the divergent environments. I will explain it later. And bug reproducibility. We want developers to be easy. We want bugs to be easy to reproduce. So for all school procedures, a team came to us, say, I need an environment. Okay, we check the capacity in physical servers, in virtual machines, containers. We are using Proxmox, so we put the bundle in one container, and then we operate the environment. Everything is manual here. Manual or maybe semi-automated. We have some Jenkins jobs that produce the final environment. But on the first time, this is manual. We are basing our installation scripts on rsync to move code from one place to another, and it is very IT friendly, saying that way. And we have to check that the configuration in those environments are not colliding with another existing servers. For instance, the ports of the servers or the properties, etc. So we have to check that manually. And okay, you are at your day off, and the next guy has to deploy, and you are not there. So you have to read the documentation, your wiki page, internet, and probably the exact thing you need is in the sysadmin head. So you cannot reproduce the environment. It's completely different. One thing you need, and that thing is not there. So this configuration made by hand produce divergency. So we have two environments, and they look alike, but they are not the same. So that's why dev servers are not production servers. So who has a developer configuration exactly the same in production? None of us. So that's true. Operation system, CPU, RAM, everything is completely different. And even further, developers' laptops. The configuration of packages, what you have installed, the version of Java, everything could be completely different from laptop to laptop. So do you know this sentence, pets or cattle? Who knows about this? I hear. Okay. You create a server and you choose a powerful name, Thor. This is a very good name for me. It's strong. My server is robust. Okay. I'm very happy with him because he's very strong, very fast, runs very smooth. But I'm very sad when Thor fails or shuts down because I'm out of memory exception and I have to kill it or shut it down or maybe replace with another instance. Oh, I have a copy of it 30 days ago. Okay. But imagine you are able to stop it without taking care of the server. I don't mind. The other way with Thor, you are treating the server as your lovely pet. You are taking care of it. If it dies, you suffer, you cry. But imagine the other way. You can kill it when you need. If it is performing bad, just kill it. Just replace it for another one. This is what we call the pets or cattle metaphor. So if you want to run fast, you want to deploy fast, you want to be responsive with incidents, you need cattle. So we choose cattle. The third problem we have is what we call bugs reproducibility, or the difficulty for us to reproduce bugs. So this is actually the first reproduction of a bug, 1950. So And this complexity is produced by this one, this slide. We have different source code, master branch 6.2.x, 6.1, so different operating systems, different application servers, and different database. This is very complex to keep track of the bugs. So if you take a look at we were talking about that yesterday too. This is the matrix support. 35 combination without operating systems. So please, compassion about our developers when they have to find a bug and reproduce it in any configuration. So we start to think that we need something better for us, a way to make life of developers better. We started with the list, and we found that developers don't want to change context. They want to stay in their Git workspace without moving away. So changing context forces them to stash or create a whip commit and then go back to their branch and build it. So they don't want to move. Again, they want to use they want to use an already built environment. They prefer doing that than doing it for themselves. If I have to build it after moving, maybe the next time I come back to my branch, the real branch I want, I don't remember what it is. So I have to build it. I want an environment that has been already built for me. And of course, using automated procedures. Although we have very smart guys that create a script that automates for them, but maybe that's not a developer-friendly approach. So they prefer automatic things than they don't repeat yourself techniques. So this is the system we love. A modern and easy to use system, a system that builds environments in an automated way, reading for the source code from Git. We want a system that stores the environment produced by the system itself in a place that developers can reuse it. And we want to increase the autonomy of our teams. We don't want them to rely on IT and wait for 1 month for an environment. We want the environment now. So, of course, yes. Involving the IT in this generation of the system, we are putting them in the line. They are not at the end of the line on the development process. They are inside the process. So this is very similar to what the DevOps culture means. So having IT inside. OK. Those were the problems: environment divergency and bug reproducibility. We found that the system we want is the system that reproduces environments. And that's when Docker is the best approach for us. So let's explain the system we have. We are based on Jenkins. It's our continuous integration server, automation server, sorry. And we build everything with Jenkins. So we have created a set of builds on top of Jenkins that's allowed to create the system. Everyone knows about Jenkins, but what about Docker? What is Docker? Docker is a container. Docker is a company. Docker is a company. We have to distinguish between containers and Docker. Docker is a company that provides support over containers. So if your boss or your customer say, no, I want Docker. No, I want containers. I want Docker containers. So let's stand it clear. So a container is much lighter than a virtual machine. A virtual machine needs a hypervisor to virtualize the hardware. With containers, we are virtualizing the operating system. Okay? And to run an application, we need operating system. And this increases the footprint of the virtual machine over containers. So we have 2 problems there. Not a problem, but differences with containers, hypervisors, and operating system. If you add the cost of the license of the operating system, you see the difference more clearly. And the container, runs the application instead of the operating system, like VMs, does it in the user space memory of the kernel. Well, But Docker, as I said, is the standard de facto. So everyone knows about Docker and create the relation with Docker and containers. But there are other technologies, Rocket, OpenVC, LXC. But the model that Docker provides with images is very famous and well-tested, and it's based on layers. That is a very efficient model for creating images. The disk space that an image can be in the file system is very reduced if you have many layers many images that share layers. Oh, sorry. And the tooling around that ecosystem is very, very well known. We know Swarm, that is from Docker, Kubernetes, all the tooling for the command line interface and REST API. I think I don't know if the WeDeploy team is here, but they play with that command line interface a lot. So these are our roles. This is the system. We define 4 roles: the Docker registry, the Docker engine, Docker builder, and of course we want the developers to run the system. So we want the works on my computer. So the Docker registry is Docker Hub is a public IT infrastructure hub where you can download the images you need. Someday you realize that the Apache you need, Apache with some configuration, is in Docker Hub. Instead of having your IT doing it for you, you just fetch, adapt, and use. That is Docker Hub. So they provide also a Docker image for that registry that is named private registry. You can install in your companies under your firewall and start working with on-premise registry. So we created a virtual machine with a lot of space for storing images, and with Docker Compose, that is a tool that allows containers collaborate. We created the registry. We have Apache proxy and a registry, so all requests to the registry pass through the Apache. We added security with OpenSSL, and this is the URL to configure everything. It was hard for us, but we found the key. Okay, the second role is the Docker engine. Docker engine and Docker daemon is the same. If you hear that, it's all the same. It's just an operating system package. It provides the application infrastructure and runtime dependencies in a standard way. What does it mean, runtime dependencies? Well, root file system, network stacks, process hierarchies, variables, whatever you need from your operating system is here. Runtime dependencies. And Docker provides you in the same way. What does it mean? If you move your container from another engine to another engine, it behaves the same. That's the most important thing. You move your container to Amazon, it works. You move to JCE, it works. You move to Azure, it works. You move it locally, it works. So it's like a shipyard. Do you know the analogy of shipyards? Everything is created, everything is built on top with containers in mind. The ship, the shipyard, the cranes, the railways, everything around containers. So standardized. Well, we created a virtual machine again for every team. And this is a laboratory for them. They can play around with their containers, their images. There is a virtual machine for collaboration, another virtual machine for web experience management, another for front-end development, another for platform. So we created VMs for them. And we provision those machines with Ansible. Remember, pets. Sorry, cattle, not pets. We want those machines be the same, exactly the same. And then we run inside Liferay images that are created and pushed to the registry. We run those images with Docker Run on Docker Compose if we want to add the database, for instance. And we have a policy of removing containers every week or so. This is the engine. But why VMs? I'm talking about containers and why VMs? A VM is very useful for us. A VM can be moved from physical host to physical host. And we can back up the VM. It's only just one file. So we can back up that VM completely, and we have a backup of all our containers running inside. And in terms of security, if one team drains the resources of the machine, we don't want other teams to suffer that. Okay. And the third one is the Docker builder. It's based on Jenkins. We are generating on the fly the Docker file for the project. And we fetch the code, we read the hash commit of that branch, in this case master, and generates a Docker image from a Docker file on the fly, on the slave. And we do it every night. We want developers to start working with an image, a fresh image in the morning when they come to work. So the Jenkins slave also pushes to the registry, and then is publicly, not publicly, internally distributed across the company. Again, we are deploying here. The Jenkins slave is deploying that image to a Docker engine and change some configuration in our Apache and adds the service. We have an environment name we call master that you can test everything you want in the features that were created yesterday. So we have a continuously live environment to create features. And it's very useful for the teams. The UX guys here can tell them their experience that they have everything from the day before. So for them, it's useful. So now the bundle is Dockerized. We have an image instead of a bundle. And we can distribute that, and it's more easy. It's easier to operate. Okay? And how do we name those images? We have a private registry, we have the GitHub repo, and the branch and the hash, the commit. So that's the name that's the name that identifies an image. We also add a timestamp, because if you tag an image with at the same point, they don't occupy the same space. So it's very, very easy for us. So although we have two images here, it's only one image on the disk. This is an example of where URL, the Liferay portal, the branch, the hash commit, and the timestamp. And this is very useful for us, because we can reproduce an environment from one day to another. If I want to reproduce portal state yesterday, I go to the repository and fetch and grabs the image. And they don't want to be online, just fetch, and I can go in a flight for 10 hours, and I can try, and I can test my image. Okay? But we want to even go further, and we want to enable feature branches for developers. We want a developer to create a feature, and we want them to create an image for that feature. So it should be that way. So this is on work in progress still, but we want to create for my user, for instance, for that feature, in that commit, fetch the code, generate the image, and publish it. So you can, if you are in a team, you can send to your QA team an image of the feature, and they can test it. So it's very, very easy for us. This is a diagram of the system. So the Docker builder just pushes to the repository and sends the image to the engines they need. So it's very, very easy for us. And if we are in a development mode, we can run it from Windows, Ubuntu, Linux, or Mac, and everyone can execute the images in their machines. But in their laboratories, in their images, but also in their local machines. That is one of the points of the system, enable them, to execute the exact environment. So, just finishing, the benefits of the system is that we have less dependency on IT. We don't wait for them 1 month or even more. We have teams more autonomous, or this is our goal, and we want both developers and non-technical users can build images. So imagine you have to go to a customer with a demo, a showcase, and this is the image you have prepared for everything. It's very easy for them to have it baked, pre-baked. And with training, it's super easy. Writing an image, a Docker file is 5 minutes. For Liferay, 5 minutes. But the problem is operating that image in a system. But for our purpose, it's super easy. OK, just to summarize, define your strategy for continuous delivery, minimum pipeline, build, test, and deploy, minimum. Build your Docker image in that pipeline, publish your images to a repository, distribute it again across your teams. It will be the cause of more autonomy on your teams, and definitively will increase the development of your speed because you will have everything done. So that's it. So thank you. So
thank you, Manuel.
And
as you already expected, we have time for some questions. So please raise hands.
Please vote me.
Very spontaneous. Thank you.
Hello.
Hello.
You said you are not using Docker for production servers.
Yes.
Yeah. Do you have experience with production and Docker? Maybe you are using Docker service. It's a new feature in the last version.
Yeah, but not as I said, in Liferay we don't have that production step. So it's just things that I can play around in my free time. So I don't have a professional experience.
Okay. I have one question more about Liferay. Is difficult to write a Docker image for Liferay in the last version? For DXP, as example?
For DXP, DXP, remember, is a product. It's a set of products. So you have Liferay Digital Enterprise and a set of different Liferay screens and so on. I'm not the guy who has to do that. But you have images here. These are my GitHub and Docker Hub repository. I'm publicly releasing this mine. Images. So you have the last one I created is the Liferay DE7 GA1, I think. So it's there.
Cool. Thank you.
So you can start playing around with it.
Yep. Anyone else here?
Hi.
Hello.
I'm running Docker in production, for that matter, but I will challenge you a bit. Because Docker instances are supposed to be agnostic, so everything should be inside the Docker, right? The same goes for the license of Liferay. So the license of Liferay can be either production, non-production, or developer. So our question is...
Yeah, but I said, I don't think you said the first slide. This is about development processes. So
I will tell you, it's an impossibility with Liferay currently to do this. So
we have customers that are moving that are using Docker in production in Spain. We can talk with them how they are doing because it's a support topic. So I'm not the one who can talk about it. But I can provide you the information. So if you're interested, just talk. Let's talk later.
Okay.
No. It depends. So the question is why we are using Docker? We are running Docker images or running Docker composed images? That's the question. It depends. Sometimes we want to have just the instance without database, just to quickly fire a library. But sometimes, from some environments or some live environments, we need a database, for instance. So we run it with Docker Compose. We create the Docker Compose file and start it. So it depends.
Yep. Thank you. And we heard that before. It depends, right?
So Liferay does a lot of things during the deployment process, like when deploying a hook or a next environment. When will this happen in this Docker scenario? When you build the container or the image, or when you run it? This
is my opinion. You should create the image with your plugins, not throw it to the running image.
Yeah, but do I put them in the deploy folder within the image, so when Liferay starts up, they get deployed? Or otherwise I have to do it at build time, I have to deploy the server so I can package it into the image?
I would put it in the deploy, or maybe if you know the exact path, just copy the jar files to the OSG folder, just to be there when the runtime starts.
Okay.
But create the image before. Mm-hmm.
Sorry, they can't hear you. No, but the others might be interested. So.
Okay, how do you deal with the fact that usually developer licenses are single instances and perhaps your production system is a clustered environment?
So,
in addition to your license file problem.
So can you repeat
when you build up your Docker instance or your Docker environment during development process, you usually use developer licenses which are not clusterable. But perhaps your production environment would be a clustered environment. And even you have the problem that our colleague here references with the different license files for the different subscriptions.
Yes, we don't like that because this talk was not about clustering, but let's talk later. So it's complicated. It's a new scenario about production and clustering with Docker, so we have to face it. We have some customers that have success with that. We can talk later. So we can write a blog post or just send me an email. I don't know if it's here about it. So let's talk about it, please.
So for the licensing question, you can always use Liferay Connected Services instead, and that stores the data in the database.
Oh, yes.
So you can jump between dev, stage, production, whatever, and your licenses can be clusterable, not clusterable, and you can incur hourly charges on that. So you can actually spin up whatever you want and spin down whatever you want, and your licenses will adapt automatically in DXP. This doesn't work before DXP. It's brand new.
Yeah.
How much work is your upgrade? LCS doesn't exist for 6.2. It's brand new for DXP. If you're still going to be doing file-based licenses, which are still possible in DXP, but we don't really do, if they're still file-based, I'm not really sure. Ansible, use a deployment like that, something like that, to change your license files around per environment.
So think yourself if you need Docker in production for Liferay. I mean, I think this could be another good question. Thank you, Brett.
All right. Thank you very much.
Thank you. Thank you, guys.
Manuel, for your explanation.